All right, guys, here's the video that I said I was going to make, going through a few more examples, kind of dealing with some limits at infinity. There is a little change of plans. I'm not going to do any trig stuff, just because trig functions with how they behave kind of work a little bit funky, and I want to be kind of in person for that. So rather than looking at some trig stuff, I do want to give you kind of another way to look at some of these limits, and how we can maybe evaluate them a little bit quicker rather than having to divide by like x to the fourth everywhere each time. Rather than doing that, if you look at the exponents within the numerator and denominator, and really the ones that matter are the biggest ones, and usually those are the ones that come first, so 3 and 4. If the exponent in the numerator is smaller, like in this case 3 is smaller than 4, then really what's going to happen is this exponent of 4 is going to be the most, I guess, powerful or kind of impactful thing. So essentially what we're going to end up with here is 0 over infinity, which is just going to be 0. Okay, so rather than having to divide by x to the fourth everywhere and do that algebraically, say if you just kind of take a look at your exponents, so at least with polynomials, stuff like that, say if the numerator is smaller, we end up getting 0 overall for our limit. Okay. On the flip side, and I'm going to tweak an example here. So let's make this. Let's make this to the third and squared real quick. If we have something where our exponent on the numerator is bigger, then essentially what we're going to end up with is infinity over 1, which is just infinity. So if your exponent in the numerator is bigger, say then we end up with infinity. Okay, numerator smaller degree, we get 0. Numerator bigger degree, we get infinity. If we have the case where they are the exact same, so like here we have x squared, because again, none of this really matters, okay, because the most powerful or most meaningful thing within these functions are going to be the things with the biggest exponents. Those are going to be where we take these giant numbers and take them to the second or third or fifth power, whatever it might be. If your exponents are the same, then essentially these cancel, and your limit is just this number divided by that number. So in this case, our limit would be 2/5. Okay. So we can have 0, we can have infinity, we could have negative infinity, potentially depending on, say, the exponents that you're dealing with or something like that. Or we could have a whole, maybe I shouldn't say whole number, but we could have a rational number, say like 2/5 or 1/3 or 4/7 or something like that. Say if we end up with the biggest exponent being the exact same, okay, in the numerator and denominator. Okay, so maybe if that helps a little bit, kind of evaluate those things a little bit quicker, awesome. What I'd like us to kind of try to do with those now is kind of work with that idea to maybe evaluate limits with some other things going on, and not necessarily trig stuff. But maybe it's been a while since you've seen the natural number e. Okay, that's the 2.718. So you first kind of learn about it in Algebra 2, and then maybe you see it again in college algebra. We could potentially be looking at like the limit of e to some power or something like that. I know this, say, pops up on, say, the worksheet that I printed out for you today. If we kind of review what the natural like e function looks like as a graph, say it's this thing here that kind of gradually goes up and to the right. And so if we have the limit of e to a positive infinity, basically we're looking at e as we go further and further to the right. Okay, as we get further and further that way, well, our function is just going to be getting higher and higher and higher. So our limit as e goes to infinity is just going to be infinity itself. Okay. If we ended up with the limit of e going to negative infinity, well, that could be, or that would be our our value as the function goes further and further left. So basically the left-hand behavior, well, this is getting closer and closer to 0. Okay, and we have like a horizontal asymptote at 0. So our limit as e goes to negative infinity is just going to be 0. And then if we have our limit of e as, or e to a number, okay, not infinity or negative infinity, well, then that's just going to be e to the whatever that number is. Okay, and that we could evaluate with our calculator. Okay, and that I would probably just end up turning into a decimal in the end. If you wanted to leave it as e to the 4/5 or something like that, you could. If you would prefer decimal, like I said, that's perfectly fine. Okay. So if we kind of combine those ideas, say what we could do is kind of do what we just did on those last couple examples, focusing on this part here, and try to figure out what is that kind of rational function, or what is that exponent kind of going towards as we kind of plug in infinity. And again, if I kind of take that same approach, that, okay, I look at my exponents 2, and technically this is 1. Since my exponent on top is bigger, this whole fraction thing is going towards infinity. So this is basically asking me the limit of e to the infinity, more or less, which is just going to be e, oops, sorry, that's just going to be infinity itself. Okay. Okay, so if I look at another one kind of similar to that, again, I'm going to focus on this part here first, try to figure out what is that thing getting closer and closer to as we kind of plug in infinity. So if I compare exponents here, well, they're the same. Again, none of this, say, really matters. So if they're the same, they'll basically cancel each other out. And so we've got 3/5 in this case. So my limit, as x goes to infinity, of this whole e to the kind of crazy looking fraction thing, this is just going to end up being e to the 3/5 power, which again, if you wanted to leave it like that, you could. If you'd rather go with a decimal and call it like 1.822, say we could absolutely do that as well. So either or for those ones. Okay, so if we've got these kind of crazy looking fractions or functions within, say, other functions, whether it's e to the something, or we'll look at kind of another function that we could be dealing with as well here in a sec, we can kind of take say this idea that we kind of used up here to evaluate these sorts of limits a little bit quicker, say, and then kind of use that within a bigger function. Okay, so if we look at another one that I know pops up on that sheet that I printed out, is the ln, or the natural log function, which is one that goes hand in hand with that e function. And again, if it's been a little while since you've seen this, say the graph of a natural log function looks like this. So if we kind of keep in mind, okay, what would an ln, or what would a natural log function be doing as it goes to infinity or negative infinity or something like that, so we can maybe find a shortcut or find a way to evaluate that limit a little bit easier. And so if I ended up with like the limit of ln of something that's going to infinity, okay, so maybe I get another one of those fractions that goes towards infinity, well, that is just going to be kind of the right-hand end behavior, which I know it looks like this thing is kind of leveling out. Technically speaking, though, this is still gradually getting bigger and bigger and bigger and bigger, just really, really slowly. So that would tend towards infinity, say, as, say, our ln gets bigger and bigger and bigger. Natural log is a little bit kind of funky, and this is also kind of where trig gets a little bit funkier as well. And like I said, that's why I want to kind of be there in person, say, for you guys on that one. The domain of an ln function isn't all real numbers, okay? So technically, the ln, or natural log function, would not be defined as x goes to negative infinity. So we don't really have that. So what I would kind of try to compare that to, usually rather than going towards a negative infinity, say that would go towards 0. So maybe your function is something, excuse me, say something similar to one of, say one of these like first ones where like your function tends to 0 as you plug in infinity. Maybe we end up with one of those inside our natural log function. And if that's the case, then that limit as ln of 0, then that would go towards negative infinity, because as I get closer and closer to 0, my function gets lower and lower and lower. Okay. And then like before with the e function or e to the exponent function, if you end up with ln of a number as a limit, then say the limit of that is just going to be ln of whatever that number is, which again, that's something you could probably evaluate with a calculator, say in one way or another. But so if we look at a couple, say with these ln functions, again, I'm going to focus mainly on, say, this part in here, okay? And I'm going to try to maybe use, again, that same trick to try to evaluate this a little bit quicker. So I'm going to look at biggest exponents. We got 3 and 2. So I got the bigger exponent on top. So this is basically turning into ln of infinity, which the ln of infinity is just going to be infinity. Okay. So if we look at another one, so I've got, again, kind of a rational function or a polynomial rational function inside this ln function. And so again, I'll focus mainly on that inside part and look at, okay, I've got exponent of 2, exponent technically of 1. So what that is kind of giving me on the inside there is 0 over infinity, which is just going to be 0. And so this is ultimately asking me more or less, what is the ln of 0? Or maybe I should say the limit as x approaches infinity, but that's going to be negative infinity. Okay, because technically if you were to plug in, say, the limit or the ln of 0, your calculator is probably going to give you, say, an error message, because the domain should be greater than 0, so that might give you a little bit of a problem. Say if you were to try to like plug in ln 0. Okay. So then one more here, just kind of looking at like that last scenario involving an ln function. Again, so if we focus on this part first, let's just figure out what that's doing. Is it going to infinity, negative infinity, 0? Is it going towards a number, something like that? And here again, I'll look at exponents. So I got 4 and 4, so those are the same. So essentially what I'm going to do is I'm going to look at what's kind of the leading coefficients of these things. What are the numbers in front? So I got 5, and technically there's a 1 there in front of that x to the 4th. So this is more or less kind of asking me what's the ln of 1 over 5, which, again, if you wanted to leave it like that would technically be our most accurate answer. Okay, if you wanted to plug that into your calculator, say, and get a decimal, say you absolutely could. Unfortunately, I don't have a calculator in front of me that has the ln function on it, or at least I can't find it. So I'm going to just leave it as the ln of 1/5 here and call it good. Like I said, if you are more comfortable decimals, if that feels more complete to you, that is perfectly fine if you want to switch that. Okay. So again, hopefully, say just maybe that little kind of extra or maybe quicker way to evaluate some of these limits helps a little bit, rather than having to divide by x to the 4th or x squared or whatever it is every single time. So maybe gives you a little bit of a quicker way to do that. I will say if you start getting into some of those square root functions, then that like dividing by x or x squared or whatever it might be, say might be a little helpful at times. But say, like I said, hopefully that helps. Say at least gives you a little bit of direction, say on a day when I'm not there. But if there's anything that you're still struggling with, anything you still want help with, I guess right now I am planning on another day at minimum, kind of dealing with these limits at Infinity, where we can look in some trig stuff, where we can look at some other kind of more funky, kind of complicated things, and I can kind of answer any questions that you have. So if you have any questions, say make note of them, say write them down,